So this video we're looking at plotting cubics, which is following on from our work last video, which was looking at plotting quadratics. So today, this video we're looking at plotting cubics. And important to note with this, right, we've looked at quadratics, right, in the previous video, which was either way you've got something like this, which in the basic form is y is equal to x square. So the important part is it's got a square power, or a quadratic, right, it could have had a, it could be going in the opposite direction like this. And the basic shape for this would be y is equal to negative x squared. Today, we're looking at cubics, okay? And the important thing with the cubic is when you see the equation, right, you're looking out for a power of 3 in that equation. So this here, right, this is going to be the basic, it's going to be in the basic equation of y is equal to x cubed. So literally, right, a cubic, it has a cubic power. So the 3 there is the power. Okay, you could also get a cubic that looks a little bit like this, so it kind of like in the opposite direction, so similar but just reflected along the y-axis like this, okay? And if it was in this direction, it's still a cubic, but you would get a negative x cubed. So really it's just recognizing, right, if you see an equation, which we'll see in a second, like in these examples here, with a cube as the highest power, or in example 2, a cube as the highest power, right, it's going to be either this red shape if it's positive x cubed, or this blue shape if it is negative x cubed. It's just about recognizing your graphs. So quadratics have a square power, cubics have a cube power. Anyway, let's begin with plotting a cubic. So we've got two examples, with the first one being a little bit easier, the second one being a little bit trickier. Right, and the first thing before I even get into my table of values is just recognizing, right, because this x cubed here, it is positive, right, it's kind of, there's no negative there, it's going to look like this red one, okay? So it's going to be, it should roughly take kind of like this kind of shape, roughly. That's not very well drawn, but something like that, roughly. Okay? Anyway, so let's plot the graph of y equals x cubed plus 1 between x is minus 2 and x is equal to 2. So we can see that on our table of values, we're going from minus 2 to 2. So if this is our x-axis and this is our y-axis, right, we're literally going from the point minus 2 to the point 2 over here. Let's begin. Substitution. So when x is equal to minus 2 to begin with, right, I put it into my equation. So y is equal to, and definitely use brackets here, right, x is equal to minus 2, but this time I'm cubing it. So minus 2 cubed, and then I'm adding on 1. Okay, if you use brackets here, you could just type it in your calculator, but it might be a non-calculator question. They come up in both. How do you evaluate minus 2 cubed? This means, right, this part here means you're doing minus 2 times minus 2 times minus 2. Well, negative 2 times negative 2 is positive 4, so this bit here goes to positive 4, and you're timesing it again by negative 2. So positive 4 times by negative 2 is equal to minus 8. So if you're cubing a negative number, you will always get a negative number out. So minus 2 cubed is equal to minus 8, and I'm adding on that 1, so my answer goes to minus 7. And if you could use a calculator, you could type that in using the brackets, and you should get minus 7. But let's look at it without a calculator to really think about it. I think that's a good way of doing this. Okay, your second value, when x is equal to minus 1, we go and do the same thing again. X is minus 1, we put it into our y equation. So y equals x cubed plus 1. So y is equal to x cubed, where x is equal to negative 1. So minus 1 cubed plus 1. Okay, and similarly again, right, minus 1 cubed means minus 1 times by minus 1 times by minus 1, okay, which is going to equal to, well, 1 times 1 times 1 is 1, but if you're cubing a negative number, it comes out as a negative, as shown up here. So minus 1, add 1, which is equal to 0. There we go. And when your numbers become 0 and positive, it becomes a little bit easier to look at. So we're now looking at when x is equal to 0, we can put it into our equation. Y is equal to x cubed, where x is now 0. We're cubing it, and we're adding on 1. 0 cubed is 0, add 1 is just equal to 1. So we've got 1 going in there. When x is 1, let's do the same thing again. X is equal to 1. We put it into our equation. So x cubed. So 1 cubed plus 1. Right, 1 cubed. 1 times 1 times 1 is equal to 1. Plus 1 is equal to 2. There we go. When x is equal to 2, we go and put it in. So x is equal to 2. We get y is equal to 2 cubed. So 2 cubed plus 1, which is equal to 2 cubed is 2 times 2, which is 4, times 2, which is 8. So 8 plus 1, which is equal to 9. Okay, so I've got my table of values. like on the previous video, I go and plot these points as coordinates, and hopefully I get a graph that looks something like this, a positive cubic shape. So let's do that. So I've got -2 and -7. So -2 across and -7 down is going to be this point here. -1, 0 is going to be here. 0, 1 is here. There we go. 1, 2 is up here, and 2, 9, there we go, is up here. So good, right? If I plot this using a freehand going through all of these points, and it's tricky to do on my screen, but I try my best to do it. That's not too bad to begin with. And we keep going. Something that's not great, that part. So something like this. That's not bad at all, actually. There we go. And you could keep going through down, but that is good, right? It is roughly in this shape. Well, it is in this shape. Okay, and I plotted my points correctly. If I had a point that was like, I don't know, for this, if I plotted this point like way down here, I would know it was wrong because I would get something that would look like that. Well, clearly that's nowhere near the shape that I want. So that's why it's really important to be able to recognize the kind of shape graph that you want, because you can tell if you get a coordinate that is drastically wrong, you can check that point. Okay, that's example 1. Example 2 is a little bit trickier, but let's go through it. Okay. This one is saying plot this graph, y is equal to 3 minus x plus 2x squared minus x cubed between x is -2 and x is equal to 3, which is just saying again, if that's my x-axis, that's my y-axis, I want to go from -2 all the way up to the point 3, okay? And again, right, you might be thinking, well, there's a square there, is that not a quadratic? No, because the highest power, which just means like the biggest power that you see, is that 3, a cubic. So it is actually a cubic function. Right, and because it's got a minus x cubed, this part here, we know going all the way back to the first slide, right, if you've got a negative before the cubic, it's going to look like this blue kind of cubic graph. So it's going to be kind of going in the opposite direction like this. That's going to be the rough shape of this graph, hopefully. So we know when we plot our coordinates, it should roughly look like this. Okay, let's begin, right, from x being equal to -2, and then we just substitute our values into our equation really carefully using brackets. So we get y is equal to 3. Subtract, write it in, your x value, which is equal to -2. So put it in using a bracket, that's really important. And we're adding on 2, and my x value is -2, and we're squaring it, so -2 squared. Subtract my x value, which is -2, and we are cubing it. So you can see, right, when you've got loads of squares and cubes going on, it's so important to use brackets, otherwise it becomes a mess really, really quickly. Right, let's evaluate this really carefully. You could put this into your calculator using the brackets if you can use one, but let's work through it, showing what is going on. So we've got 3. We've got take away -2, which really means, right, 3 add 2, because you're taking away cold air, you're getting warmer by 2. So that really, this bit goes to a +2. So 3 plus 2. We've then got plus 2. I'm going to keep this 2 here, and let's go and evaluate -2 squared. Well, -2 squared is equal to +4. So 2 times by 4. Not a very nice bracket. There we go. Let's write it a little bit closer. So 2 times 4. Take away. And then write -2 cubed is, again, -2 times by -2 times by -2. So -2 by -2 by -2, which is equal to -8. Because this first bit gives you a +4 times -2 gives you -8. So take away, in brackets, -8. So brackets are just really, really important, particularly with these negative parts. So 3 of 2 is equal to 5. 2 times 4 is equal to 8. And then take away -8, that becomes a plus again. So plus on another 8. So 5 at 8 is 13. Add 8 is equal to 21. So when x is -2, we get y being equal to 21. A bit trickier, these ones, because you've got loads of squares going on, cubes going on. It's really easy to make a mistake here. That is why brackets are crucial. Right, so now when x is equal to -1, let's go and put that one in. X is -1. We're going to get y being equal to 3. Take away my x value, which is now -1, plus 2x squared, where x is equal to -1, so -1 squared. Take away x cubed, where x is equal to -1, so take away -1 cubed. So y is equal to 3. Take away -1, again that becomes a +1, plus 2 minus 1 squared, just this bit here, becomes positive 1, you're squaring a negative, so 1, take away this bit here, so take away that bit there, and in the bracket we've got minus 1 cubed, again, well minus 1 times by minus 1 is plus 1, times minus 1 again gives you negative 1. And that's all, put it all together, so we've got 3 add 1 is 4, plus 2, take away minus 1, so plus 1, so 4 add 2 is 6, add 1 is equal to 7. So when x is equal to minus 1, y is equal to 7. And that's kind of like, these are the two trickiest ones because you're dealing with negatives, which can get a bit awkward. So it should be easier now, we're just dealing with positive numbers over here. So let's kind of speed run through these ones now. When x is equal to 0, we're going to get y being equal to 3, take away x where x is 0, plus 2 times x squared, so 0 squared, take away 0 cubed. Okay, and that's going to be equal to, well, 3, take away 0, 2 times 0 squared is just 0, take away 0 cubed is just 0, so it's just going to be 3 is our answer. So when x is 0, y is equal to 3. And let's do the same thing with 1 now. When x is equal to 1, 1's going to be quite an easy one to do as well, because it will just keep it the same. So y is equal to 3, take away x is now 1, plus 2 times 1 squared. There we go, take away 1 cubed. So 3, take away 1 is 2, plus 2 times 1 squared, well 1 squared is 1, times by 2 is plus 2. Take away 1 cubed is just 1, so take away 1. 2 and 2 is 4, take away 1 is equal to 3. So when x is 1, y is equal to 3. Let's keep going. When x is equal to 2, we're going to get 3, take away my x value, which is now 2, plus 2 times x squared, so 2 squared, take away 2 cubed. Okay, so 3 take away 2 is 1. 2 squared is 4, so 2 times 4 is positive 8, so plus 8. 2 cubed is equal to positive 8, but it's take away 8, so take away 8. Well, 8 to 8 is 8 take away is 0. I've got the 1 left over, so 1 is my answer there. Okay, almost there. When x is now 3, I put it into my equation, so 3 take away x, where x is now 3, plus 2 by x squared, where x is equal to 3, so 2 by 3 squared. Take away 3 cubed, so that's going to be equal to, well, 3 take away 3 is 0, 3 squared is 9, times 2 is positive 18, so plus 18. 3 cubed is positive 27, but it's take away 27, so take away 27. 18 take away 27 is equal to negative 9. I think, yes it is. Negative 9. Good, so that is my answer for this one. Okay, a good kind of check to make sure that it's going to be roughly right is your y value should be between, right, your biggest one is 21, your smallest one is minus 9. Hopefully it fits on the grid. It does, and it does. Good, so it should hopefully be roughly correct. And again, we're looking to get this kind of other S-shape cubic graph. Let's plot our points. So minus 2, 21 to begin with. So minus 2 across, 21 up, which is going to be this point here. Minus 1, 7, so minus 1 across and 7 up, which goes here. 0, 3, which is 1, 2, got my eyes, 1, 2, 3, this point here. 1, 3, which is this point here. 2, 1, which is here, and then 3, minus 9. And this is good, okay, because I'm getting this kind of S shape in the opposite direction. It's going to look something, right, a smooth curve going through all of the points, something like this. And it's really hard to do by freehand, but I'll try my best. That's terrible. Let's try again. So through the points, sorry, it's really hard to do on this, but there we go. Good. And then we keep going, we keep going, we keep going. Good. And we go down. Right, and there we go. Again, it's really important to know that we know that the rough shape, okay, is going to be like this, because let's just say, right, we plotted a coordinate wrong, particularly about like one of the negative ones, which is harder. Let's say we plotted this one to be, I don't know, down here, right? We would know definitely, right, that, well, if we just had this graph here, that is nothing like, right, this. So it's really important to check that we roughly know it should be in this shape. Sorry, that point was up here, wasn't it? Minus 2, 21. And that is it. That is plotting cubic graphs. And actually, this came up this year. If you did the OCR paper 6, it came up around question 10. So this stuff comes up. Usually, right, they won't make you plot the whole table of values because you'd be there all day. They might just give you like 2 values to plot, for example. But that is it, essentially, right? This stuff comes up most years, so it's a really important topic to know. So next video, we'll get onto either exponentials or what's the other one? Reciprocals, probably reciprocals, and then exponential graphs. Okay, thank you.